So I want to give you just a little bit of background about Evans Sutherland that not many people know. And when I was sending out all these messages to various people, a friend of mine turned out he worked for Hembrecht and Quist in the 70s and 80s. That's a company that brought a lot of companies public, including Apple. Something very interesting he told me. 1978, H&Q brought Evans Sutherland public. That was one of 5 companies they brought public that year. The other 4 fizzled away. E&S made it. Their prospectus valuation was $50 million, and E&S delivered what the prospective promised. Nobody else did that. Sales increased by 10 times in 10 years, from 10 million to 100 million. Some of those numbers these days have gotten much more amplified from that, but in the day, that was pretty incredible. The stock price increased 10 times. It's a pretty amazing story. It shows what the true heart of the company was. It was based on the people from the university. And Evans and Sutherland, I mean, it's a testament to that. So I just thought that was an amazing bit of history. So Alvy Ray Smith is our MC for a couple of our events here on the stage today. He was one of the expert reviewers for this milestone, as I noted. He was the author of a biography of the Pixel. I invite Evans Sutherland and also Bob Schumacker to the stage right now, please. And a little bit more about Alvy. You can sit here, Alvy. His biography of the Pixel book that I mentioned already is really a first-hand history of computer graphics, because he lived this, and it's just amazing reading. So I encourage anybody here to read that. It was a key, as I noted, it was one of the key references that I used within this milestone to vet the information. And it truly, throughout the whole thing, it talks about the impact of Moore's Law.
How do I click?
Let's see, you click using this. So we need both Ivan and Bob Schumacher on the stage, please.
Here they come.
Oh, here they come, okay.
Just go ahead and start.
If you want to give some background information, sure.
That's what I'm going to do.
Yeah, go right ahead.
While you guys are coming on stage, I'm just going to start with a little introduction here, okay?
Yeah, go ahead and talk into the mic, you bet.
Into this mic, all right. All right, 1957, a lot of us remember this amazing event when the Russians put up Sputnik. And almost immediately, 1958, just a few months later, ARPA was formed. How does this thing work? How's this work?
What's that?
What do I push?
You should be able to push that. Actually, you won't see the slides, unfortunately.
It's right there.
Oh, actually, you got them right there. Okay, great.
There you go.
There we go.
ARPA was, what'd you push? That green
I
one?
pushed the green one. The big
Oh, the
green
big one. Okay, all right. ARPA was formed. Just a few months later, it was the U.S.'s first response, and then a few months after that, NASA was formed. So we're going to talk a little bit about that as starting the scientific revolution in America. Evans Sutherland, one of our 2 panel members here today, pursued the ARPA branch. Now, that's him as a young man, upper left. He's got a robot, I think he built at Carnegie Mellon, if I'm not mistaken. And to the right is the famous sketchpad. It's Ivan exercising the famous sketchpad, which was the first time that people had got the notion that humans could have agency over the computer. They could actually change the design of pictures on a screen themselves. And everything that we're talking about today descends from that. The funny looking thing at the bottom is Ivan's head-mounted display. That's not Ivan, but that's his device. Actually, that's just the head-mounted part. The device is huge, and we'll talk about that more later. And in the corner, of course, is Dave Evans with Ivan, the founding fathers, and in a sense, Ivan is representing Dave here today. And there were a lot of Turing. These guys won lots of prizes. The one I'm going to pick out is the Turing Award because it's the most impressive to me. Alan Kay got one, I haven't got one. My partner Ed Catmull got one. So this is a big deal. I won't say, if I were to list off their awards, that would take all the time we have. Bob Schumacker is representing another man, Rod Rougelot, who couldn't be with us today. But the two of them represent a different approach. I've got the symbol, the NASA symbol there. It's not the same idea. ARPA handed out money to people, and they got to do research the best they knew how. NASA pursued the more traditional issuing of our requests for proposals and granting of grants, in this case, to General Electric, who built, with Bob Schumacker and Rod Rougelot's help, simulators of the Apollo project. You can see Bob in the lower right there. I love this picture.
Hardly recognize.
Yeah. Who is that guy? Yeah. Looking at the guts of the NASA 1 for space simulator in 64, 65, something like that.
64.
64, yeah. Okay. And the big circle in the center is NASA 2 that they built, which I think was an amazing machine because it showed the first color pixels. This is in 1967. The first color pixels, the first full shaded color graphics, and it was all moving in real time. Awesome. And it was hidden away, so they didn't get to, a lot of people didn't know about it. And that's Rod Rougelot down there with in the lower left with Dave Evans, just to remind us that Bob's representing Rod also. So let's get started. Just keep that on the screen. Of course, they came together at Evans and Sutherland. They came together at Evans and Sutherland. Should I stand here in order to?
That's your mic. Right there. No, it's right in front of you, right here.
I know, but can I take it over here?
Do you have your own mic? Oh, okay.
I think I'll just sit here. So I can sort of see.
We have my name, yeah. See each other.
Yeah. Spread my copious notes down here. I'm going to start with you. I want to thank both of you. You helped me out. The book got mentioned, and both of you helped me out a lot in writing that book, and I appreciate that. One of my burning questions, Ivan, is it has to do with when you first showed Sketchpad. I think your dissertation was 63, but I think you showed it somewhere in 62. Was it IFIP or AFIPS or one of those? What did you actually show? A movie?
A movie, yes. There was a movie made. It was kind of flickery because the movie camera and the screen were not synchronized.
Right.
But we showed that, and it was, I think it was AFIPS, was the big computer conference in those days. And I was just a youngster. I didn't have any idea what we were doing. I just went.
So
There it was.
So what you told me you had to, you told me you had to walk through the computer, TX2, in order to get to the console.
TX2 was a big machine. It had 250,000 bytes. And, it was a big machine. And it ran at about 1/10 of a MIP. It was a big machine. I mean, it was really a big machine. And I mean that in the literal sense. It occupied a big room. It had rows and rows and rows of transistorized modules. It was TX, the transistor experiment. It was built with 50,000 independently manufactured transistors in little pillboxes with 3 wires coming out of each one. They were surface barrier transistors, lovingly handcrafted, each one individually, by the Philco Corporation at a cost of about $50 each. You do the math. Okay. Now, I got to use that machine as my personal computer.
Right.
I didn't get to take it home. I had to go there, and I went there early in the morning. I was just a graduate student, so I got, the wee hours of the morning.
So let me ask you, I've asked you this online, but I want to ask you in public. You walked into that machine, there's a display, it's a dot display of some sort, and you told me you grew up reading blueprints before you could read English. So apparently, I took from that you knew how to visualize from blueprints into 3D or something like that. Is that?
Oh, yeah.
Yeah, okay. So I assumed that all that there was on that display at the time was text. Is that right?
No.
There was already graphics
It was
on
the
it?
bouncing ball, and somebody had made a program that you could turn the knobs, and it did Etch-a-Sketch. So you could turn this knob, it would draw a horizontal line. You turn that one, it made a vertical line. Can't make very nice drawings that way. It's hard. And we got a light pen. And what you see in the movie, you see me moving the light pen, and you see that cross shining out of the light pen onto the screen, right? It's like a little flashlight. It shines that cross onto the screen to tell the computer where the light pen. No. The cross shines into the light pen. And there's a piece of code that, says, I think the light pen is going to be there the next time I look. And so it displays a little cross there. And
Did you have to write that code, or was it already?
That?
Did you write that code?
Of course.
Yeah, I thought so. You had to write everything, right? Yeah.
Yeah, there was no operating.
There was nothing, right? Okay. Just trying to put it in perspective here with the leap you made.
And object orientation wasn't known. Nobody had done that.
I thought it was a brilliant move to have made the movie. I think that movie was what a lot of us learned, how we learned about Sketchpad.
Yeah, if I hadn't made the movie, nobody would have known what we'd done.
That was a great marketing move, Ivan. So ARPA formed, and guys like Licklider, they basically handed you the money bags to hand out for information
Now,
processing.
this is a long story. You see, Licklider had started this big program at DARPA. And my first introduction to that was when I was invited to go down to MIT and show my movie to a bunch of bigwigs from Washington. And they were there trying to learn about what computers could really do and so on. And Licklider had brought this collection of people up there. And then Licklider started this wonderful program. And what he did, he was a government official, and he went around to all the top computer people in the country. He knew them all. I mean, the man was wonderful this way. And he went out and he asked them, what should we do? And then he started a program in DARPA, and that's what they did. I mean, what a nice way to figure out what research you should do is ask the researchers. I mean,
So tell everybody how old you were when you got appointed.
I was 26 years old.
26 years old.
I was doing my military service. I'd been commissioned a second lieutenant in the U.S. Army, in the Signal Corps, of course. And I'd done my basic training, and I'd gone to Fort Gordon, Georgia, and done all the stuff, and run around in the woods and set up signaling systems and so on. That's where I met Quint Foster, who is the man who's in the picture of the head-mounted display.
Oh,
we were
okay.
Army buddies. He's been here. I don't know if
he
he's
here?
here today. But anyhow, then Licklider decided he was going to leave. He went off to IBM, I think, and there was no director. And so they asked all the reasonable people, and nobody would say yes, because it was a civil servant job. Very low pay, very difficult job, a lot of, pushing and shoving to figure out how you get a budget. And nobody would take the job. And so they finally asked me, and I couldn't say no. I was in the Army, I got orders.
So is that how you got to know Dave Evans? I mean, he was already being supported by ARPA, right?
David was one of the contractors. Dave Evans had a contract from Licklider at Berkeley
Yeah.
to figure out how to do time sharing. And that's how I met Dave Evans. He's one of the contractors. You know, that collection of contractors was wonderful. The one that helped me the most was Al Perlis. I organized a meeting one time because I thought we ought to have a common character set. And Al Perlis walked in and he said, yeah, I'm in favor of a common character set. We should all have a common character set. Ours is available. And that, you know, that put the thing in context. ASCII hadn't been invented yet. IBM was using IPSIDIC, and you know, other people were struggling, and then the teletype code was common because teletypes were the cheapest way to get a keyboard connected to an electrical signal. And the teletype is an amazingly reliable machine. I mean, it just works and works and works and works.
Okay, I'd like to talk about the head-mounted display a little bit.
Oh, that's
So I guess you handed out money at ARPA for a while, and then you went to Harvard and built the head-mounted display.
Then I had to take a job, so I took the job that had the lowest pay. I mean, that's clearly the sensible thing to do. I was an associate professor at Harvard.
I have a wife who's a professor. I hear these stories all the time.
So I had visited the Bell Helicopter Company, where they had put a head-mounted display on a helicopter pilot with an infrared camera underneath. So the helicopter could land in a clearing at night. He could see the trees and so on, figure out how to land safely. And they had done the important experiment, which was a person is sitting in a comfortable office chair in his office, and the camera is mounted on the roof, and there's a couple of people playing catch. They throw the ball back and forth, and the guy is watching, and then they threw the ball at the camera. And of course he ducked. He thought he was at the camera. And the only insight I contributed is we can substitute a computer for the camera. I mean, why bother with a camera when you can use a computer?
Can you describe to people, I mean, we just saw the picture of Quentin wearing the head-mounted part, but this was a beast, right?
Well, there were a couple problems to solve. We had to do the geometric transformations in real time. There was no computer in the world that could do that at that time. So we had to build the equipment to do that. And there was a graduate student from MIT by the name of Chuck Seitz who came over and helped us. He taught us how to do this. And so Bob Sproul was part of the team, and we put together all this equipment to do this real-time transformation. And then there was the problem of where is the person looking? Which direction is his head facing? And there was a very good mechanical engineer who made a thing for us, which was a telescoping tubes, which had measurement stuff in it, so it could tell how long the tubes were. And at the bottom, there was a gimbal with a couple of shaft encoders, and at the top, there was another gimbal. And that was, that was the system. And that sort of partly supported the weight of the head-mounted display and measured where the guy was looking.
How heavy was it?
Well, I don't know. There's a spring in the telescope.
Right. So I'd like to bring
Please do.
Schumacker and Bob Schumacker into the picture here, and Rod Ruggelo. How did you get to know each other?
Sorry?
How did you get to know each other? Either one of you can answer, or both of you?
Well, the first thing is we didn't get to know each other when we were both in Cambridge at MIT in 1960. We did get to know each other. I think the first time was 1968 when you and Dave came out to NASA to see the system down there that was generating some very crude 3D objects in the ground plane. You were just starting your company, and I don't know whether we knew that or not when you came out to visit. So the visit was a little strained. We enjoyed showing it to you, but you started asking questions. And
Sometimes I do that.
yeah, I noticed that. And so I think there were fairly simple questions like, how did you do that? the answer that I gave was vectors being volants on this. So then they wanted more detail, and I said something about, well, it's cross products and dot products. And I think that was about the level of the exchange. And I think this was in the evening, if I remember correctly, when NASA wasn't using the system. But we established a nice contact on that visit, and Dave reciprocated by inviting us out to Utah and sat in on, I guess it was Warnock's thesis. Was that in '69? Yeah. So it would have been John's.
Oh, okay. So one of the questions I want to, or subject I'd like to tackle is, you came together here eventually, but you had two different approaches to the future of pictures on computers. You were generating things in real time from the very beginning. In other words, you would spend as much money as it took to put it into hardware. And Ivan was using, and his students later were using, general purpose computers and writing Moore's Law basically into the future. Is that a safe distinction?
And I distinguish them by saying one is interactive, the other is real time. You know, interactive you can probably think of as you go out to buy something at a store these days online, and you get to manipulate the thing around and look at it. And that's interactive, but it's not real time. Real time means you do it every 60 times a second.
Is that what NASA 2 was, 60 times a second?
I forget, but it was probably more like 50 or something.
Yeah.
We needed all the time we could get to make the images.
Okay.
But I think the group, your group, made the Evans Sutherland company work. You had done stuff that was dead simple, that did the job. And we were trying to do something that would do something much more complicated that was needed. And, you know, we were doing the scientific thing. You were doing the right engineering thing. Make it dead simple, make it work.
Well, NASA wasn't simple, but the next thing we tried.
The next thing you tried
was. We learned our lesson.
Okay, we're running out of time, unfortunately. Several of the marvelous graduate students from your school have referred to the vision. Did you ever explicitly express a vision for your group? And if so, what was it? I think yours was let's have an inexpensive real-time pilot's assistant or something like that.
Well, our goal was to cover the spectrum. I mean, we realized that pilot training was probably lots of them, even though lower cost. But we also wanted to do the ultimate stuff that was real time for the military because they were the ones that could afford it.
In the last seconds, do you want to give a stab at it?
No, I don't think I understood where this was going. I knew that graphics would be important for teaching, for learning, for doing scientific things. But, you know, what the future would be, I had no idea. If you want to know what the future from now is going to be, ask the young people. They're going to make it.
Okay, I'm afraid we have to shut it down. I'm really sad. I've got a lot of other questions. Okay.
Hey,